So let me start today's lecture. So as usual, please log in into the web safety system. So today is the last lecture, okay? So we have two remaining contents. So first I use A2-C slide, okay? So today's topic, first half of this lecture, its topic is function recursion. Do you know recursion? Maybe you know mathematically recursive function. Do you know? No? No? Structural content is shown here. The first, we introduce a function. The why do you have to define the function? And how to declaration of the function. And I also introduced example programs about the declaration of the function. And after that, I introduced recursion. Okay? So especially recursive function. And I introduced some functions, factorial or summation and GCD. And I also introduced the detail of the execution step of recursive call. Okay? And also introduce some example programs. And finally, I introduce exercise. Today, the exercise. So as shown here, when you have to define the new functions. So maybe as you know, can you imagine? You can imagine. So some frequently used procedures. Such procedures, once you define the functions, after that you only call such functions instead of writing such a procedure, such as sentences. Okay. So already the compiler system, a programming language C, provide standard functions, library functions. For example, several new input-output functions, keyboard input or display function, and file input-output or string operations, as shown here. Those are all functions. So if you want to define the new function, you have to know how to define the functions. So this is a general form. So always a function has a return type. So you have to specify return type and function name, and several functions need several arguments. Okay. So inside the brackets, you put several sentences. Frequently used sentences, procedures. Okay, so this is the example. This case is plus a function defines the return value is integer, and argument has two arguments. So both arguments are same type, integer type. Okay, so plus is defined as the name of the function, and A and B are treated as the local variable. So local variable means only available inside the bracket, inside the function. Okay? So also you can define the local functions besides these arguments. Okay? Inside the function. Okay? Inside the function. Such variables are also local variables, only available inside the function. Okay? Inside the definition of the function. Okay? So this is a very simple function, plus, so this function returns A plus B value as a return value. Okay? So this is another actually example program. So this case is a sum mention function defined. The function name is sum, SUM, and return type integer. Arguments are 2 arguments. So first argument is treated as a set of data. So set of data is an integer type array data. Okay. So the variable is defined as a pointer to specify the location of the array. Okay. And the second argument is the size of the data, array size. Okay. So using the 4 functions, so maybe you can imagine not so difficult, very easy. The var is var has a total value of some set. So by specifying the I, so each data is specified, and each data is gradually added to the var WA variables. Okay. So after that, this function return total value. Okay, as a return value of this function. These are main functions. Okay, this case is 2 data defined array data as array data. So this is the 5 data and 10 data. Okay, contents are those. And using printf function and function called sum, you can display the total summation of these values, or these values here and here. Okay. So this is the content is almost same as the previous program. However, the definition is somehow different. So in the previous program, the sum function is defined before main functions. This case is sum function defined after main functions. Okay. So this is correct. This is also correct. So however, you have to put the prototype definition for these functions, because the compiler, if you don't put this prototype function, prototype definition for these functions, main function, inside main function, the compiler don't know what kind of the return value of this function and what kind of the arguments need for these functions. The compiler don't know. So to teach such information to the compilers, you have to put the prototype definition of some functions. Okay. So here you only write the return type and the function name and the argument type and argument number. Okay. So, do you have any questions about the definition of functions? No? So, next topic is recursion. So, some cases recursive function is very convenient. So, in mathematics, there are some recursive functions. For example, factorial. Do you know factorial? Maybe no. Usually, n factorial is represented as n exclamations. Okay. So n value, range of n value is 0 to any integer numbers. Okay. So this is the definition of a factorial. Factorial of 0 equal 1. Factorial 1 is also 1. Factorial 2 is 2 multiply 1. So it's 2. Okay. So this is the definition And as an algorithm, you can define the factorial functions like this, okay, by using a recursive call. If n, this algorithm calculates the factorial n, okay, so if n equals 0, the factorial n should be 1, factorial 0. Otherwise, so n is larger than 0. Such cases, n factorial equal n multiplied by factorial n minus 1. Okay? This is completely the same the definition of the factorials by recursive call, using recursive functions. Okay? So this is a recursive definition of the factorial as a recursive function. Okay? Function name is factorial, and return type is integer. Argument is only one, integer type. Variable name is n. Okay? So if n equal, this is a predicate. So 2 equal is a check the equal or not. So n equal, if n equal 0, return 1. Okay? Otherwise, this function calculates n multiplied by factorial n minus 1. Okay? So this is completely almost the same as mathematical expressions, recursive definitions. So using several slides, I introduce how to calculate the actual factorial n. This case is you specify the 3 and 4 variable n. Okay, so the program has to calculate the factorial 3. Okay, so of course the factorial 3. Very easy to calculate. The answer is 6. Okay. So, however, the inside program, the program calculates as shown here. So first, if you specify factorial 3, this function called, and in this case n is 3. So not true. So this part will be executed. In this case, n equals 3. And factorial n minus 1. N minus 1 is 2. So also you have to, in this case, also you have to calculate factorial 2. Okay? Like this. So to calculate the factorial 2, this function also called. However, this case n is 2. This is not true. So this part also will be executed. This case n is 2, and n minus 1 is 1. So you have to also calculate factorial 1. Okay? So factorial 1, this function also called, and in this case n is 1. So this is not true. This part will be executed. In this case n is 1, and factorial n minus 1 is 0. So you have to also calculate factorial 0. So factorial 0. This function also called n is 0. So this part is true. So just return 1. Okay? The return value of function factorial 0. So once factorial 0 is calculated, you go back to the previous page. So factorial 0 can be calculated as 1, like this. Okay? So this part also calculated 1 multiply 1. So factorial 1 also become a 1. And furthermore, you can go back to the previous part, and you can calculate factorial 1. Its answer is 1. So this part will be calculated 2 multiplied by 1. So factorial 2 also calculated. Its answer is 2. Okay? Furthermore, you can go back to the first part. Okay? So factorial 2 can be calculated as 2, integer 2. So this part will be executed like this. So finally, you can obtain the final answer, 3 multiplied 2. Its answer is 6. Okay? So can you understand? Do you have any question? No? So this is the actual program for calculating factorial. This is a definition of factorial, function factorial. Function name is factorial. Argument is n. Okay? Both are integer type. And this is the main function. So several times you can enter any value, and this program calculates each time factory, the corresponding input number. Okay. So in fact, the summation, a function sum, also defined as the recursive functions. Okay. So definition of summation of n in mathematics are using the recursive function, recursive call. If you specify the n, integer n, the summation function calculates the total number of 1 to n. Okay? It's a summation function. So if n equals 0, then of course the return value is 0. So otherwise, n is larger than 0. In such cases, summation n equal n plus summation n minus 1. Okay? So mathematically correct. Okay? So this is actual program corresponds to this definition. Okay? So sum is a function name, and n is local variables treated as arguments. Okay? If n equals 0, the return value should be 0. Okay? Otherwise return n plus summation n minus 1. Okay? So as I explained the previous execution detail for factorial. So this recursive call also executed very similarly. Okay? This is the main function. So final example is GCD. Do you know GCD? The greatest common divisor. Okay. No, GCD 6. Okay. 2 multiply 6 plus 3 multiply 6. Okay. Ah.はい。Okay. So there are several algorithms to calculate the GCD. So very famous algorithm is a Euclidean algorithms. Okay. So of course you need two integer values. These two values. So this case is A should be larger than B. Okay. So first you have to calculate the R. R is treated as a remainder of A divided by B. Okay. So if R equals 0, in such cases, GCD A and B should be B. Okay? Otherwise, not equal 0. GCD AB equal GCD B and R. Okay? This is the Euclidean algorithm. So this part is a recursive call. So this is definition of mathematically. Okay. So in a program, you can specify the DCG like this. The function name is DCD. Return type is integers. You need two arguments, A and B. Okay. Both are integer type. And a local variable. Also you need R as a local variable. Okay? So first you have to calculate R as a remainder of A divided by B. Okay? After that, you have to check the R value equals 0 or not. If 0, R equals 0, the return value is a B. GCD, if R equals 0, this case is GCD A and B should be B, become a B. Okay? Otherwise, not equal 0. R is not equal 0. GCD AB should be GCD B and R. Okay? So this is the end of the first half part of today's lecture. Okay. So afterward, please try to this today's exercise. So the last content of this lectures. So this content also introduces two famous programs: the binary search program and quick sort programs. Those programs are also defined as recursive functions. Okay. So in fact, I prepared these two programs. Inside the program folders, binary search.c and the quick sort C. Okay. So you can check using these two source programs. So first algorithm is binary search. So do you know binary search? Maybe no. So the binary search algorithm is also search algorithms. If you have any data like this, stored in variable, stored array data V. First element is 0, second element is 2, 4, 6, 8, 10, for example. Okay? So the search program have to check the input data is included or not these data. Okay? If the corresponding data is 6, the 6 is matched to this element. So this program return the position of the data. The actual value is 3. Okay? So if you specify the 8, the program search the 8 number in this data. And actually, the program can find such data at the position 4. Okay? So this program returns value 4. So if you specify 5, actually 5 is not included in this data. So in such cases, this program returns negative value as meaning of the mismatch, no match. Okay? Cannot find. So maybe already you made one such programs, a very simple program like this. Okay, so if you have n data, you can check n data one by one. Each data is equal to the specified data, input data, or not, like this. If you can find the match data, the program return the position of the array. Okay. So functionally, this is enough. So, however, the calculation cost is not good, especially n is very, very long, very large. Okay. So in such cases, binary search is effective. So detail of the algorithm of binary search is as shown here. Okay. So you have 6 data. Such data stored in array data. Okay, and you specify the x values, and the program have to find the specified value is equal any of the data. Okay, so binary search algorithm first center value is used to divide two groups. Okay. If the specified value is less than center values, okay. So in such cases, x, if there are any match data to this, such data should be located the left part. Okay, because the x is less than the center values. Otherwise, the x should be located right part if the x is larger than center values. Okay, so of course you have to also check the specified value is equal to the center value or not. If they equal, the program can find the position at 3. Okay, otherwise this part or this part, the program divides this part and this part. Okay. So the similar operation apply to the left part or right part correspondingly. Okay. Then finally, the program can find the match or equal match or no match, not match. Okay. So can you understand? So this case is the average calculation cost is 2 by n by 2 average. So n is a data size. Okay, so binary search is log 2n. So if n is very large, so this value is very effective value, become effective. Okay. So this is a description of the any like a sentences of T program. Okay. So as I explained, you have a 6 data. Okay. So you have to first find the center values. This case is 6 data, and 2.5 is the center value. No. 6. 3 is the center value, becomes center values. Okay. Then you have to check the specified value is less than center value. In this case, you have to also search that specified value in left part of center values. Okay. So because x should be located in this part, because x is less than the center value. Okay. Otherwise, if x equals center value, then the x completely matches to this position. The program should be return 3, okay, as a position. Otherwise, the x should be located in the right part, because x is larger than center values. Okay. So recursively, this part is also called as binary search programs recursively. This part is also can be calculated as a recursive call of binary search. Okay. So these two sheets are completely actual program of binary search program. Okay. So this is a prototype definition of binary search function. This case is 3 arguments. This is the searched value, and this is the data set, and this is the size of data set. Okay. And this main function, first this program make initial values multiply 2. Okay. And using a scanf function, you can enter any value to be searched. Okay. And finally, using printf function and binary search functions, this program returns the position of the corresponding value. Okay. In the data set. So this is the main part of binary search functions. Okay. So do you have any question? No? So anyway, I prepare the binary search program the other WebCT contents here. Okay. So if you want to know the detail of the execution, please try to make an execution program and try to execute this program. And the second program is quicksort. Quicksort is very famous sorting algorithms. Okay, so very fast sorting algorithm. So its name is quick. This sorting algorithm is also defined as the recursive functions. Okay. So algorithm, the basic idea of quicksort algorithm is similar to the that of the binary search programs. Okay. This is the initial data. Okay. Not sorted. Okay. So you have to sort like this. Okay. So first you put the first elements. This case is 3. Okay. Then you have to check the remaining data smaller or larger than the first elements. Okay. So this case is 3 is selected. So 0, 2, 1 is a less value. And 5 and 4 is a larger value than 3. Okay, so you can divide 2 groups by first element. Okay? Okay? Like this. So this is the first element. And this group is each element is less than 3. And each element is larger than 3. So you can divide 2 groups. Okay? And the similar operation applies these group. Okay? So first you select the first element. In this case, 0. So using 0, you can divide 2 groups. Okay? So as a result, you can obtain this order 0 to 1. Okay? And this case 5 is selected and divide 2 groups 4 and 5. Okay? So this case is only one element. So you don't need any more to divide. And this is 2 elements, so you have to divide. So first element is 2. So you can divide 1, 2. Okay? And these are group are only one element. You don't need any more to divide. Okay? So as a result, you can obtain the data, sorted data like this. 0, 1, 2, 3, 4, 5. Okay? As I explained, the select first element and using such an element to divide left part and right part. Okay? This is the basic operation for quicksort. This operation is applied to the next step. Apply to each of the divided 2 groups. Okay, the recursively, this function called, this operation will be called. Okay. So this is actually program of quicksort algorithm. So you can change the element positions. First, you have to define the swap functions. Change the position of the two elements. Okay, swapping. And the main part of the quicksort is here. Okay. So actually, quicksort algorithm is called here. Okay. So last part is the main function. Okay. So this case is main inside the main function. Randomly, data max size is 10. Maybe 10. So max size is 20. 20 random value will be generated and stored to the data set, data array data. Okay. And using printf function, first such initial data will be displayed on the computer screen, and using quicksort functions, data is sorted, and finally using printf function, the sorted data will be displayed. Okay. So oops. So this is the end of today's content, and almost the end of this class lecture. Okay. So remaining time, please spend prepare the homework, or maybe some student have any exercise not submitted